Welcome, everyone, to the Plant Services Podcast series, The Hidden Cost of Compressed Air, sponsored by Kaeser Compressors. Each podcast in this 4-episode series will tackle one of the many facets of compressed air system operation and costing. I'm Tom Wilk, the Chief Editor of Plant Services, and today I am joined by two compressed air experts from Kaeser, Neil Meltretter and Wayne Perry, for a discussion on the hidden costs of location that can be associated with your compressed air system. Neil is Technical Director for Kaeser Compressors, and he's conducted and supervised thousands of industrial compressed air studies to help plant teams achieve significant energy savings and operational improvement. And Wayne Perry is Senior Technical Director at Kaeser Compressors and has more than 40 years of experience in all aspects of the compressed air business. Welcome, gentlemen. Thanks for being part of the special series today.
Thanks a lot, Tom.
Yeah, great to be here.
I'll direct the first question at Wayne. Wayne, the first episode of our series focused on the cost of oversizing, and we ended that conversation by talking about planning a new plant or expanding an existing system. So I'd like to start this episode by touching on that topic in the context of location. What are your thoughts on when you're planning a new plant or expanding an existing system? What are some of the considerations on where and how to install your compressors?
If you're talking about multiple compressors in a new system, then it really makes sense to install the compressors and the air treatment in a central location. It makes controlling the compressors more efficient because the master controller can get a signal from an air receiver and control all the compressors based on the pressures that it gets at that downstream receiver. It also makes sense if you've got the room to install it in a central location or midway down the plant, just so that you don't have extremely long runs of piping. And speaking of piping, I would say that's one of the things that's really overlooked in installing compressed air systems. If at all possible, upsize the piping so that you can do future expansions without having to go back and install bigger pipe or more pipe in there. That's all critical. Another thing to consider when you're looking for location is if the machines are air-cooled machines and you need to ventilate the heat out of the building, then you're going to need to be close to a wall or some other way to get, up through a ceiling to get the air out of it. But those are the primary things that I would look for when you're considering locations. You might also consider, which are the most critical applications of compressed air, which are the most pressure sensitive. Maybe put the system close to there. What I would recommend against is installing one compressor on one end of the building and another compressor on the other end of the building, because you're never going to get a good pressure signal to be able to control those efficiently. Neil, do you have anything to add?
Well, I was planning on adding a lot, but I think, Wayne, you covered pretty much everything. There's, we talked about it in the pre-call. We could probably talk for days on any of these one topics. I think Wayne's points are definitely valid. Safety, noise, what else is in the compressor room, those things, do tend to come up. But yeah, Wayne's points were definitely the ultimate challenge for us and the things that we want to consider when we're looking for a place for the compressors.
One of the things that, I got into this business back in the 70s, and compressors were loud, and you wanted to put those machines as far away from people as you possibly could, because they were, 85, 90, 95, sometimes even 100 decibels loud. Today's compressors have gotten so quiet that you can put them in with the people working on the factory floor, and they're going to be much quieter than the machines that are doing the actual production. So that's no longer a real consideration in this equipment.
That's an interesting advance to point out. Neil, since Wayne also mentioned ventilation before, maybe I can ask you the next question. In your experience, how does ventilation impact compressor performance when you're considering location issues?
Sure. I think it's probably one of the most important things. Bringing in the cooling air and removing the now warmed up cooling air, if you would, discharge cooling air from the compressors, and also dryers. Refrigerator and dryers also have heat buildup, and as well as let's say blower purge or heated purge desiccant dryers. Those are smaller aspects of it, but moving that hot air out of the compressor room is going to really improve your longevity of the equipment, the reliability of the equipment, and also service costs. The higher you operate the equipment, the more service you're going to need, the less your oil is going to last. Maybe the more that if the ambient environment, and we talk about ventilation is huge, but also each compressor is going to have an inlet filter, and maybe they also have filter mats. So those are all serviceable items. If the ambient is high in dust, debris, those kind of things, that's going to affect how the equipment operates. High temperatures are really compressed air killers, and we see that over and over and over again. You may not see it on day one, but you certainly see it several months into the installation, and maybe long after your service provider might not be there. So if you're doing the service on your own, things to check are what the operating temperature is of your air compressor. If it's oil flooded or oil free, then you're also the gut check is, can I open this door? Is when I'm opening the door to the compressor room, is it opening into the room? So when I open it, that door slams open and pulls me all the way in, like a bad dream, let's say. Or when I'm trying to pull the door out, it's an open out. I can't pull it out, and I'm not the strongest guy, but if it takes me two hands to open a door, I know we have a negative pressure in the room, and that's a ventilation issue. Both of those are ventilation issues. And what that ends up doing is it causes an increased compression ratio on the equipment, which means that it's working harder for that same CFM worth of air. We're very involved with Compressed Air and Gas Institute, CAGI, and those data sheets are really pivotal in helping end users figure out what compressors they need and what's that key performance index specific power. And so if you're running these compressors hotter, if there's not enough ventilation, if there's not enough air into the room or removal of that air, you could throw the CAGI data sheet out the window, because your power consumption is going to increase 5-10%, and then your reliability is going to be lower. And that's when customers start screaming, "Hey, what's wrong?"
Yeah, something else to think about as far as ventilation goes. The compressed air dryers are rated for 100-degree ambient, 100 psi, and 100-degree inlet temperature. And if you go over that, if you have a room that's not well ventilated and the compressor room is at 100 degrees, the air coming out of the compressor after it's gone through the aftercooler is probably 120 degrees. If you feed the dryer with 120-degree air, then you basically cut its capacity in half. So for every 20 degrees up in temperature you go, that air can hold twice the volume of water vapor. And you're really going to cut your air treatment capacity by a lot if you run in a hot room. The other thing to consider is that the amount of work done by compressed air is based on the density or the mass flow through the compressor. The compressors are rated in volume, but it's really the mass that does the work. And the hotter the air temperature, the less dense the air is. And to Neil's point, if you don't have enough flow into the room, you're basically modulating the compressor. You're getting less dense air going into the compressor, so you're getting less mass out. The same volume is going through, but you're getting fewer molecules of air coming out the other end. And that's hurting the efficiency of your whole compressed air system.
Okay, well, related to the issues of ventilation, Wayne, are issues of clearance space, and you wrapped up your description by talking about how ventilation issues can impact cost. How does clearance space factor into this? How much clearance do you need around compressed air equipment?
Oh, I've seen some really bad installations in my time. We'll talk about that a little later, but you need enough clearance around the compressors, certainly to swing the service doors open. But in addition to just being able to swing the service doors open, you've got to think about, can I bring lifting equipment in if I have to change a motor, or if I have to change an air end, or I have to change a cooler? Can I actually get the tools and equipment in to get that done? And, am I putting these things so close together that what would have been, a 3-hour job is going to turn into a 3-day job because I have to disassemble things to get them out? So service clearance is really important. The other aspect, and that's just from a servicing the compressor point of view. The other aspect about having a good clearance around the compressor is that you generally have good airflow around the compressor. If you have a lot of clearance, you're not blocking any of the paths. And it's also really safer for any service technician who's getting in there to work, because he's got some room, he or she has room to move around, and they're not cramped, and they're not having to squeeze into tight places. And it's a real safety issue, and that's really high on my priority list, is make it safe for people to work around that equipment.
Yeah, I would piggyback on what Wayne said in regard to the safety aspects. If you can't open the doors, then you're not going to be able to get in to do the service safely. But also in regard to NEC code and the amount of space you need in front of an electrical panel so that door can swing open, and you can do the service, and or if for whatever reason, if it's not locked out, tagged out, or something like that, you're wearing your full PPE gear, arc flash protection, etc. But if you have to egress from that site, you need to be able to get away. So even though you might need so much space in front of the panel per code, you need to be able to get from that area to a safe space. So those things are really paramount. And like Wayne said, we'll get into our not so ideal installs a little bit later, but that's part of it, is making sure that not only can we do the service, can we do it safely, can we do it in a reasonable time frame? Because that's a hidden cost. Wayne mentioned a 3-hour service might take 6 hours, could take 12, and that's something that seems amenable to the customer. Oh, we're just going to put the equipment here, and that might work. But in regard to the long-term effects, those maintenance costs are going to increase significantly. So those are things that we really recommend to think about. And then also air that has been heated up from one equipment to another. So thermostatically recirculating louvers, that's something that we talk about all the time. It's a great practice, but what if it's just blowing onto the other compressor and we have nothing to move the air? So one compressor might be fine, but the other one might be over temping because it's ingesting all that hot air from compressor one or dryer one or something like that.
I think that's a good point, Neil, and that's something that we didn't really talk about. We've been talking about compressors, but you also need to put ductwork, the proper kind of ductwork and ventilation on the dryers as well as the compressors, because they generate heat too.
We got a lot of factors to consider here, from ventilation to spacing to ductwork. So let's talk about some of those installs. You guys have seen a lot of on-site customers doing it their way, sometimes great, sometimes not so great. Without naming names, can you each talk us through one of the worst installs you've seen?
Without being able to describe the install, I mean, on some of these, if I describe the install, you have a good idea who the who the company is. But I'll tell you about one of them. I got called out to a facility because they had a 100 horsepower rotary screw compressor that they were having some problems with, and they were very upset that the machine was shutting down on high temperature repeatedly. And it was a fairly new machine. So I went out to the location, and the customer took me into the compressor room. And we got into the compressor room, and the compressor room was about 8 feet by 8 feet. It had, we went in through a man door, just a regular 36-inch wide door. And here's this 100 horsepower compressor, and there's no other door, no other window, no other vent in this room. It had a 10-foot ceiling, but the room was about 8 by 8. And I asked the guy, I said, how did you get this machine in here? And they said, oh, we put the compressor in and then built these cinder block walls around it so we could build the rest of the building. So they had installed it before they finished building the building. And with no ventilation, they had no way, 100 horsepower compressor is a 75 kilowatt heater. And a 75 kilowatt heater in a 8 by 8 room is going to get pretty warm pretty quick. So the only solution to that one, and what they finally did, was they took down one of the walls and moved the machine to another location and had to repipe their system. But that was just one of them. I've also seen compressors installed under conveyors where bulk material fell off the conveyor onto the machine, rained onto the machine, plugged up the coolers. I have seen variable speed compressors that were installed just below a place where they had to do wash down of their product. It was a food processing place, and they were doing clean in place, but the water came right down onto the compressor. And in some cases, water on the compressor is not all that terrible, but variable speed compressors have basically a lot of computer components in it. And if you get any dust or any moisture in those drives and the circuit boards in the drives, they're going to die. It's just very difficult unless you can put them in a clean location. But see, I'm the technical director. I don't have to worry about costs. So I tell people stainless steel pipe, very clean locations, cool locations, spend all the money, get it done right. And really, when I tell people, it's going to cost a lot of money to install this right, and then their eyebrows raised, and I said, it's going to cost even more money if you don't install it right. You're going to be spending a lot of money over time in poor efficiency, poor serviceability, maintenance expense, downtime. So spend the money up front, do it right up front.
Those are some hair-raising stories, Wayne. Neil, what you got for us?
Yeah, I don't know that I could really follow that one, except to say that if everyone has seen the Bernie memes from the inauguration here in January, that pretty much sums it up. If you have a compressor that's outdoors without a roof, no shed, no heaters, that's really kind of the worst installation that I've seen. And you have portable compressors. They're made to be rugged. They're made to be outside. But stationary equipment, especially like Wayne said, variable speed, variable frequency, that's really the worst. So yeah, Bernie looked cold. You just think of what your compressors are doing there as well. Areas that flood, I've seen that too. Wayne said general wash down, but I've seen compressors in locations that can flood. The one thing that's interesting that really stands out with me is talking to a service technician who was doing an installation for some auditing equipment. And I said, well, can you can you explain the wiring diagram? You tell me what the wiring diagram looks like, and I'll help you figure out where the signals are, and we can figure out where to put the equipment." And he said, "Well, I can't do both." I said, "What do you mean you can't do both?" He said, "Well, I've got one hand holding the phone. I've got one hand holding the light. I can't check anything with my meter. There's no power in this room." So, "What do you mean there's no power?" He said, "Well, we had to shut down the compressor so that we could troubleshoot and figure out where to put stuff, but the wiring for the compressor is linked to the wiring for the room. So when we killed the breaker, we turned everything off. I can't see anything in this room." So, it's funny. It's things that we take for granted, just the light switch on off. It's a funny story now, but certainly talking to the gentleman who was trying to get those signals, it wasn't fun then. So.
Wow.
Oh, and there is a world of difference if you're going in trying to troubleshoot or work on a machine to have adequate light. Like Neil said, I have been in a lot of compressor rooms where you had to have a flashlight to see, even if there were lights on board. Get those as seen on TV LED lights that just screw into the light fixture and bathe the whole place in light.
Wow. Well, let's close out today's podcast with a question for Neil about a podcast that you participated with in our sister publication, Food Processing, back in April. In that podcast, you had talked about moving compressors to an enclosed system, and I would think that would help with some of the issues we're talking about today too. Can you briefly discuss how that would work?
Yeah, absolutely. My opinion really is that end users, customers, they really care about flow, pressure, and the necessary air quality. Those are the paramount pieces to your compressed air system. And most cases, customers, how you get there doesn't necessarily matter. Certainly price, serviceability, overall lifetime cost, those things are important, but those are really the paramount pieces, and that there are no problems. So, why would you want to move the compressor room, let's say outside, or outsource that installation? And really the whys, they vary considerably. More space in the building. We're in a situation now where we're seeing a lot of customers start to expand, and they may need more facility space for that expansion. And like we just talked about, compressor rooms aren't really that desirable to be in, and sometimes you can't even see. So, moving them out, refurbishing that space, putting in production equipment, that's really a viable option. Also getting it outside of the building allows maybe easier access. Some customers about their process and their process equipment, it's very confidential, and they won't allow service providers in that area. So putting it outside also helps that. When we're looking at expansion, the costs to build an extra room, or like Wayne said, you want to have it in a centralized location. If we add a compressor, on the other side of the facility, is that really going to work well with the compressors in the original room? And it may not. So putting it in a centralized location, putting those in either a pod or a multiplex type system that are all together, it is really advantageous. The design costs can be lower. You might not need permitting for an enclosure. Those are really the reasons that we see customers going to that length. And the great part is it's turnkey. So whereas you might have to have multiple trades come in to do that work, and we're talking about larger installations, but even smaller stuff where you might have piping and ventilation, and like we said, well, you don't want to have negative pressure, so you're putting a newer compressor or a bigger compressor, you need more airflow. Now I need to punch out this wall. So those are things that can all be done prefabbed, ready to go, tested on site. You have a lot less work for the site work to do. And then, we do see some customers interested in that air over the fence option, and that makes it easier too. That, design, build, boom, we have flow, pressure, air quality. We've got reliability, we've got redundancy. Now it's on your site and ready to go. So those are the reasons that I think it's definitely advantageous to consider putting these in enclosures or packages.
Yes, and to what Neil said, if you have a specific air quality, you just tell your supplier, this is the air quality that I need, and these engineered packages come with all of the compressors, dryers, filters. The filters are in the right order, condensate treatment, all of that in one package, and they just drop it on site, and the customer takes power to it and pulls the air off, and that's all that they have to worry about as far as a compressed air system goes.
Well, thank you both for your time today in this podcast. We'll call it a wrap, and had a great time discussing the issues of hidden cost of location with you today.
Oh, thank you, Tom.
Yeah, it's been a great chatting.
Well, and that's a wrap for this episode of the hidden costs of compressed air. The next episode of the series will cover the cost of air quality, followed by a wrap-up episode on how to reveal and control costs with system monitoring. Thanks again to our sponsor, Kaeser Compressors, and thanks to Neil and Wayne for being here today, and thank you all for listening.